And I'm going to share my screen. Did I press record?
I think so.
Yeah, it's famous.
Yep, it's recording. We're good. All right. So I will try to help you get this straightened out maybe Tuesday. But today we're going to start the end of this chapter. We're going to finish this page right here today. And we're starting right here where it says add, subtract, multiply, and divide functions. Now, prior to this, everything up there is in the first packet of notes, which is to be turned in right here beside Tyler. There's only a little bit left. There's 2 topics. We'll cover both of them right now. And then today's Thursday, we'll review on Tuesday, and we're going to have our test on Thursday. Okay? On this last part, it's, I don't know, it's different. All right, we're going to add, subtract, multiply, and divide functions. So here you go. You can add functions if there's an addition in the middle. You can subtract functions if there's a subtraction. You can multiply if it just says FG and it's understood to be multiplication in between there. And you can divide functions. Okay. Now, if you remember from the beginning of this unit, a function is an equation, a graph, a set of ordered pairs where none of the x's repeat. We talked about on the first page, a function has to pass the vertical line test. Okay, so the things that we're dealing with here are going to be things that would pass the vertical line test. All right, we don't have a ton of room right here, so let me show you what we're going to do. I want you to put just really small, f of x is going to be 3x plus 1. That is a linear equation in slope-intercept form. Y equals mx plus b. So our m would be 3, and our b would be plus 1. So your slope would be 3 over 1, and your y-intercept would be 1. That's going to be our first function. Now, again, you're going to have to write really small. Our second function, I'm going to call it g of x, and it's going to be x squared subtract 4. So these are the 2 functions that we're getting ready to use for the remainder of this first part of today's lesson. Those are your functions. I could have had 3 functions or 4 functions, but we're going to keep it simple. There's 2 functions. F of x is in slope-intercept form. And g of x, let's review right quick. What kind of equation is x squared subtract 4? Robert? It's a quadratic equation. This is a quadratic. And what does, so we know it's going to look like a u. We know it's going to be an up u because x squared is positive. What is the minus 4 detached at the back going to do to this graph? It's going to slow it. It's going to drop it down 4 units on the y. That's correct. It's going to move down on the y-axis as expected. That's just a review of your transformations. That doesn't really have anything to do with what we're doing right this moment, but it's a good review. All right, so we're just going to do a few examples right here. I want you to do f plus g of 2. Let's start with an easy one. F plus g of 2. So what this is telling you to do is find f of 2 and find g of 2 and then add them together. Okay? This is telling you find f of 2, find g of 2, and then add the 2 answers. So the first thing we're going to do is we're going to find f of 2. So go to your f function and plug in a 2. So 3 times 2 plus 1, that's going to be 6 plus 1, which is 7. That is f of 2. Now, order matters. So the addition is commutative, but subtraction and division are not. So make sure you follow the order. The next thing I'm going to do is g of 2. So g of 2 is going to be 2 squared subtract 4. That's going to be 4 subtract 4, which is 0. We'll probably only do 2 of these just because I've done this worksheet a million times and I know there's not a lot of room on it. Now, that is not my answer, okay? That is not my answer. My answer is f plus g of 2. I've done f of 2. I've done g of 2. What I need to do is I need to add them together. So order matters, 7 plus 0. The answer is 7. Now, that just randomly ended up being a 0. I made that one up, so that wasn't a great one, but that's the concept. You find f of 2, you find g of 2, and then in this particular case, you add them in the order that they were given to you. Again, addition and multiplication are commutative. In other words, f plus g is the same as g plus f. F times g is the same as g times f. That's not true for subtraction. So you can't change the order of subtraction. We'll just do one more here. Let's do an f divided by g. So let's do f divided by g of negative 3. F divided by g. This is the only other example I'm going to do here. So let's try to keep it within this line. Okay, this is important. Like, you can get your stuff confused. This goes with that information, and then that goes with another part of notes. And then there's going to be another line here. I probably need to section out these notes. All right, so what I need to do is I need to find f of negative 3. I need to find g of negative 3, and then I need to divide them in that order. F goes on top, g is in the denominator. So let's find f of negative 3. So go to your f function and plug in a negative 3. So 3 times negative 3 plus 1, that's going to be negative 9 plus 1, which is going to be negative 8. Please stop me when I make a mistake. All right, next I need to do g of negative 3. Now, we are having a tremendous amount of issue with this little step right here. This is saying square x, square the whole thing. If it's got a negative, you square that. If it's got a number, you square that. If it's got a fraction, you square that. In other words, negative 3 in its entirety has to be squared. This negative is going to go away because when you square a negative, it becomes a positive, and then 9 subtract 4 is 5. Now, that's not the answer. Okay, the answer is the f at 3 function, negative 3 function, divided by the g at negative 3 function. This has to go on top. You don't get to reverse your order. So the first thing we got was negative 8 divided by g, which was 5. And that cannot be reduced, so my answer is just negative 8 over 5. That's the easiest thing of this entire chapter, is adding, subtracting, multiplying, or dividing functions. It's called combining functions. I'm going to write that on the side of the paper. This little step right here is called combining functions, and you're combining them with one of our 4 mathematical operations. The reason that this gets confusing is because the very next topic you see on your worksheet is called composition of functions, composing functions, and combining functions and composing functions is not the same. So this section is going to be called composing functions. All right, these two are not the same. You'll see that in just a second. Now, how many of you are instrumental, musical, anything like that in here? Raise your hand. Please, more than one. Yes, we know Dante has done music. He told us about that in one of our first questions.
I used to play the clarinet.
Okay. So if you list like piano, for example, when you play the piano, let me do my fingers. Usually most chords on the piano are 3. You can add and do a 5th if you want to do a whole octave. But when you play those 3, like 3 fingers together, that is a chord. Okay, and you compose music by putting different notes together in an arrangement that makes a pretty sound. We've all heard music that wasn't good. We've all heard somebody playing the piano or the organ when they struck a wrong chord, struck a wrong note. You know what that sounds like. Composing music means that you're putting multiple notes together, possibly multiple instruments together, to make one joyful sound, one pretty sound. With me? All right, same thing in math. Composing functions means that you're putting more than one function together to make one joyful equation. Now, it's not the same as what we just did. I will say I'm going to use these two functions. So I'm going to stick with these two functions right here. I'm going to let those be my compositions. Okay, so let's start with an easy one. So example 1, let's do, well, let me show you, there's 3 ways to write this. You can do G parentheses F parentheses X. That's one way to denote a composition. Notice that I didn't add, subtract, multiply, or divide. Another way you can write it is just to use a bracket. So G bracket and then F parentheses X. It's important that you can look at a problem and tell whether or not it's a combining or a composition. It's not hard though. If it is a combining, it has to have an addition, a subtraction, a division. Now this is where things get tricky right here, is if it's a multiplication versus a composition. I'm going to tell you how you can indicate that. Those two get confusing. And the other way is to put a little G and then a tiny open circle. It has to be an open circle. And then F of X. These are 3 ways to denote that you have a composition of functions. Let me tell you how you would read it. Here you would say G of F of X. Same thing here. G of F of X. Same thing here. G of F of X. You say the word of between each of your letters pretty much. And the one that gets confusing is this one in comparison to compositions. Okay, but I'm going to show you how you can denote that. Do you notice that on these compositions, you have some type of separation between the G and the F? Here I had a parentheses between the G and the F. Here I have a bracket between the G and the F. And here I have a teeny tiny open circle between the G and the F. If you have something separating the G and the F, then it is not multiplication. If you compare that to up here, there is nothing separating that F and that G. So that means that's a multiplication one. All right, so we're going to start with an easy one. Caleb, give me a negative integer. Okay, -4. So let's do F of G of -4. That's just what he said. F of G of -4. Now, the order matters. That's not the same as if I had put G in front and F in the middle. That would have been a different problem. But what I said, I made this up with the help of Caleb. F of G of -4. This is not a multiplication because I have this bracket separating the F and the G. So it's a composition because of the bracket. Now, I have the rules right here. Start closest to the X and work out. All right, Caleb, what X did you give me? -4. And what letter of the alphabet is closest to -4? G. This is easy question. Because this says start closest to X and work out. This is his X. He gave it to me, -4. What letter of the alphabet is closest to -4? So that's where I'm going to start. All right, just ignore this for a minute. So let's do G of -4. So G of -4, we go up here. We're going to use the same G that we had in the combining. Remember, I talked about this. This is squaring the entire value of X. So Caleb's got to square the entire -4. And then he's got to subtract 4. So it's going to be 16 subtract 4, which is going to be 12. I'm going to keep my finger there because I don't want you to look at what's under my finger yet. Oh no, I just poured my drink out. No. Tissues right here. I had to pick my finger up because I spilled my drink. Hold on, let me put my finger back. All right. Now, look at your notes. It says start closest to x. Caleb gave us -4 as his x, and work out. So we start the closest one to -4 was g. I haven't even looked at f yet. So Caleb evaluated g of -4, and he got 12. Everybody with me on that? All right, take your pencil, your pen, your highlighter, whatever you're writing with, and scratch this out. It is no longer there. In place of g of -4, we just found out there is a 12. So now I move my finger, and I need to do f of 12. So now I'm going to do f of 12. I go to my f function, which is up here at the top. So I'm going to do 3 times 12 plus 1. That's going to be 36 plus 1. And the answer is 37. The answer is not 12. The answer is 37. You start at the innermost function and you work your way out. Do not put a box around 12. Same thing up here when we were working on these compositions. 7 is not my answer and 0 is not my answer, but my answer is 7 plus 0. Same thing here. -8 is not my answer. 5 is not my answer, but -8 divided by 5 is my answer. So when you do these compositions, you start on the innermost function closest to x, and then you work your way out. Now, it's hard to believe that this is on the final exam, but it is. There's one of them, and I'm getting ready to show you one similar to the final exam. So the final exam looks a little bit more like this. Let me think about it for a second. Let's do f and then put a little tiny open circle g of x. Let's do f of g of x. Now, for whatever reason, this trips people up. Caleb gave us an x last time. It was -4, but this time I'm not going to ask anybody for an x. We're just going to use x. We're going to use x as x. All right, so let's look at our rules. It says start closest to x. Okay, Colin, what letter is closest to x? The G. Okay, so we're going to start here. Okay, I'm just going to, all I can do is write it down. So G of x is x squared subtract 4. I can't plug anything in here. I don't have a number to plug in. I just told you, and this is how it's going to be on the final exam, I said just plug in an x for x. Now remember what I did. I said take your pencil or your pen or your highlighter. You are not going to need your phone. I promise. This is really, really hard. Take your pen, pencil, or highlighter, and where you see g of x, make this replacement. So scratch out g of x and instead write x squared subtract 4. The last time we had a number to drop in. We don't have a number to drop in this time. We have a function to drop in. All right, and then hiding under my finger is f. So now we're going to do f of x squared subtract 4. I should have done that in red. Just slide this down so we can see our functions. All right, these are the two we need to be looking at right here, this f function and this f of x squared minus 4. So instead of dropping in a number, I have to drop in x squared minus 4. So I'm going to go up here, and where this x is, I'm going to keep my 3, And I'm going to keep my plus 1, but where the x is, I'm going to make this substitution. So x squared subtract 4 drops in. We're not finished, but that's a start. I'm doing the exact same thing that I did with Caleb's problem. The only difference is Caleb got us a nice, neat number to plug in. This one doesn't have a nice, neat number. We have to plug in a function. All right, let's go to Robert for this, just for kicks. This is a quadratic equation. You agree with me, Robert? Okay. Is this -4 attached or detached? It's attached, so it's going to move it where? To the right 4. Very good. So we've got a U that's been moved to the right 4. This is detached, so it's going to move it up 1. So Robert's moved us right 4, up 1. Very good. And this is a 3. Now remember, it's not slope, but it's kind of like slope. So Robert, if I told you to go up 3 over 1, up 3 over 1, is that making it more narrow or compressed? Is that stretching it or is that pressing it? Stretching it. Don't forget about that stuff we learned last week. The -4 moves it in the opposite direction horizontally. So this moves right 4. The detached 1 moves it up 1 as expected. And the 3 would stretch it. All right, that doesn't really have anything to do with this, but it all ties together because we're still talking about functions. Let's distribute this 3 because we got to simplify here. So 3 times x squared is 3x squared. 3 times -4 is -12, and then we have that plus 1 out there. And so my final answer is going to be 3x squared minus 11. This is my answer. All right, let me zoom out on those notes just a minute. We're getting ready to practice that. We're just basically getting the notes. We're getting ready to practice it for a few minutes. So we only have one more section to finish, and it's down there at the bottom, inverse functions. And then when we finish inverse functions, we're going to, which that'll take us the rest of today to finish this worksheet and to practice with it. Because I just gave you a big fat practice packet, which we're getting ready to start right now. Okay? But we will finish this section today.
Can I get one?
You can come over here and get it. It's right there. All right, let's practice what we just learned. Let's start with this first page. We are on a new packet, and it's long, but one of the reasons that it's so stinking long is because it has a review that starts on page G. So this is going to be a test review. Does everybody, are there any extras? Because I'm one short. All right, Dante, let me write on this one, and then I'll, wait, here's one. Is everybody here today? I got some more in here, sorry. I've got some extras. Does everybody have that new packet that we're starting on? All right, let's just do a couple together, and then I'm going to let you practice on some of this so you won't have so much homework. Let's start with number 1. Now notice how I named this worksheet. You can tell half of it's typed, but I changed it up here. This is combining and composing. One of the things that people struggle with on the test is looking at it and keeping straight. Is this a combine, which means add, subtract, multiply, or divide? Or is this compose, which means put it all together and make one beautiful musical note? So let's look at these. All right, this is adding, yes, this is adding. This is subtracting. This is dividing. Okay, that's pretty easy. Add, subtract, divide. This one right here, how do you know that it's not composing? Because what would have to be between that F and that G if it was a composition? A parentheses, a bracket, or a little open circle. So since none of that is there, we can make the assumption that this is a multiplication. All right, y'all try those right now. Try this first section right here. I'm gonna do a couple while y'all practice. I'm gonna start on this one. get my answers that way. Y'all work on that for a few minutes. Oh, I made a mistake somewhere. I made a mistake somewhere on this one. Oh, that's supposed to be a positive 4, not a negative 4. So this is a positive 4. This is a positive, and that's a negative 1. That's a negative 1. Yeah, you're right. I put it in the wrong spot. Yep. All right, wrong spot for that one. Sorry. The answer's here. So I did that one right there, and I did this one right here. All right, let's do the last one together, step 4. I did step 1, I did step 3. Those of you that did step 2, what did you get for your answer for step 2? 5, that is correct. This one is 5. Why is my pen not working now? This is 5. And let's do step 4 together. So what we're going to do is we need to find f of 5. All right, so you go to your f function, you plug in a 5. 5 plus 7 is 12. And then you do g of 5. Go to your g, 2 times 5 plus 1, that's 10 plus 1, which is 11. That's not the answer, though. The question is, what is f divided by g at 5? So we take f, it goes on top. We take g, it goes on the bottom. And I got 12 over 11. That does not reduce, so that's it. 12 over 11. I had put my answer in the wrong spot, so please make sure that you fix that. That is combining functions. Now, we didn't do one like number 2, so let's look at number 2. Number 2 is where I didn't give you a number. I didn't give you a nice, neat integer to plug into the x position. I did give you 2 functions. F of x is 3x. G of x is x squared minus 1. Now, let's refresh our memory. This is a line. It has a y-intercept of 0 and a slope of 3 over 1. So this is a linear equation. This is a quadratic equation. So it would be an up u and it would be drop down 1. That's important because today can feel disconnected to what we've been studying. But these are functions. Okay? Now, let's read what it says. It says, find the formula for f plus g of x. So what I need to do is I need to find f of x and I need to find g of x, and I need to add them together because that's what it says, add them together. I don't have a nice, neat number to plug in this time. So I just copy down what f of x is. F of x is 3x. And then I add that to what g of x is, which is x squared subtract 1. Now, if you can, you want to simplify. If you can add or subtract or FOIL or reduce or anything like that, you want to. But is there anything I can do to combine 3x plus x squared subtract 1? No, this is a quadratic equation. I do want to make it look like nice, so let's put it in standard form. Let's put x squared plus 3x minus 1. If you left it like that, I wouldn't mark it wrong, but this just looks better. It's in standard quadratic form, ax squared plus bx plus c. All right, the next one is very similar. Notice we're being asked to divide them. So this is saying take f at x and then divide it by g of x. Well, I don't have a nice, neat number to plug in. So I just copy down what f of x is. F of x is 3x. And then I copy down what g of x is. That's x squared subtract 1. And we have not learned how to simplify rational equations yet, but let's just take it one step further because it's a good chance to review this. How would x squared minus 1 factor? This is a difference of perfect squares. So what's x squared going to split up to? X and x. What's 1 going to split up to? 1 and 1, and 1 is a subtract, and 1 is a plus. Now, you could leave either one of these as the answer. These are both okay. Those are equal. I'm just reminding you of our factor techniques. Factoring has not gone away. We have to factor quadratic equations still, so don't forget about how to do that. It's just a good time to practice it.
Number 2, put that in like the quadratic formula, gave that answer with that.
No, because he's talking about the quadratic formula here. It's not asking you to solve this. This is not set equal to 0. It is not an equation. It is a function, but they're not asking you to solve the quadratic equation and get 2 answers. Now, if we wanted to find out where it crossed the x-axis, that's what we would have to do, Nathan, is to plug it into the quadratic formula and set it equal to 0 and find out what our x-intercepts are. But we're not going that far. All right, so let's go to Daniel. Daniel, what is the difference between what you're asked to do in number 2 versus what you're asked to do in number 3? Yes, okay. So number 3 is a composing, and this is important that you understand the difference. Number 2 was a combining. Now let's go back and talk about why. Number 2, which we just finished, was a combining functions. Number 3 is a composing, and those are not the same. So how do I know? Because up here, this had add and this had divide. So since we are being asked to add in part A, and we are being asked to divide in part B, or step 2, that means we were combining them. But in number 3, I do not see any mathematical operation. I do not have addition. I do not have subtraction. It's definitely not division. Now, Robert, how do you know that it is not multiplication? Right, because there's the parentheses right here between the F and the G. So this lets me know that this is a composition. So what we're going to do is, if you go back to your notes, let's look at composition just to refresh our memory. You're going to start closest to X and work out. So let's start closest to X. All right, so the letter closest to x is G. So let's just copy it down. G of x is negative 4x. You always start with the letter that's closest to x. G is closest to x, so I start with G of x. Now, I think it's super helpful to physically take your writing device, scratch this out. It is no longer there. It is going to be replaced with negative 4x. And then what I need now is f of negative 4x. When you move out, it is f. Now I've got to go to the f function, which says take x and cube it and then add a 1. So we need to take the entire x and cube it, and then we're going to add 1. Oh my goodness, this is so good. Great. Now, we're not finished there. We have some things that we can simplify. We learned monomials the first day we ever met. But if you're a little shaky on remembering your monomial rules, what this means is take 4x and multiply it 3 times. That's what it means to cube something. So negative 4 times negative 4 is positive 16. Positive 16 times negative 4 is negative 64. You can also put it in your calculator. X cubed and then plus 1. So that's our answer, 64x cubed plus 1.
You have to get rid of the cube when we do the 4?
You have to cube the 4 and the x. You have to cube whatever x is, which in this case it's a negative 4 and an x. You have to cube the 4 and you have to cube the x. You have to cube both of them. This cubed goes to the negative 4, and this cube, this needs to be trash. Caleb, throw this away for me, please. This pen. That's trash. We have to cube the negative 4 and the x.
Does it need to be negative?
Here?
In the box.
Oh, yes. Thank you. Sorry. Negative, 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 negative. That's crucial. Sorry, my fault. Yes. Now, I told you a long time ago when we took these notes right here, first day of this unit, we talked about restricting the domain. There are 2 restrictions, no 0 in the bottom, no negative under the square root. And this is how you do it algebraically. Okay? We're going to use this for this particular problem, but I'm also going to show you how to do it graphically. So this algebra right here, I'm going to show it to you algebraically, but I'm also going to show it to you graphically. So let's look at this. I'm putting my notes right beside me so I can look at it. This is exactly the way it's going to be on the final exam. It says find the domain for the function above. All right, so find the domain for the function above. Well, let's look at our restrictions. Number 1, no 0 in the bottom. Does this have a denominator? No. It's got a 1 down there, but it doesn't have any variables or anything. Restriction number 2, no negative under the square root. Does this answer have a square root or a 4th root? No. So if there are no restrictions in the universe to this problem, 3, step 1, what do you say your domain is? All real numbers. Okay, that's one option. All reals. And as an interval, it would be negative infinity to positive infinity. Now, you can get that answer right there by looking at your restrictions from the first day we took notes. We don't have any restrictions. If the restrictions do not apply to your problem, then it's either all reals or negative infinity to positive infinity. Wait, don't turn the page yet. I'm not finished. I'm not finished on this one. But what if you get to the final exam and you don't remember the 2 restrictions, but you need to get this correct?
You just got 2, right?
2 restrictions, right, but you might not remember them in December, May, whenever you take your exam. All right, then you can graph it. Let's talk about the graph. Let's refresh our memory. We just did this earlier today. We were on our packets, and we said, all right, if you have X on the top, which it is, and it's odd, it's going to be a vertical snake. Okay, so this is going to be a vertical snake. What is the +1 going to do to that vertical snake? Move it up 1. What is this negative going to do? Flip it. Very good. So what's going to happen here is this is going to be a vertical snake moved up 1 and flipped. So it's going to look like this. This is what the graph would look like. This is 1. It's going to be flipped to quadrants 2 and 4. Even though it's an x cubed, that negative is going to flip it. Remember, we talked about doing a handstand. If you're standing up and then you do a handstand, your hands go down and your feet come up. That's rotating along the x-axis. It flips along the x-axis. Now, if you don't remember the restrictions, you can look at the graph. Because now that we know what this graph is going to do, what does this arrow indicate it's doing forever to the left? Negative infinity. And this indicates that it's going to the right forever to positive infinity. So we get the same interval, negative infinity to positive infinity, using the graph, or negative infinity to positive infinity using our restrictions. Either way, you get the same answer. Okay.